Let's first discuss what this noisy channel probability is. So for that you need to know the intuition of noisy channel. Noisy channel is nothing but a medium which is represented like this here. So a word is passed through this noisy channel and we get a noisy word at the end. So we have this noisy word and we don't know what was the actual word, the original word. In our case, this is the misspelled word which we're calling a noisy word now, and this noisy channel, this could be the keyboard. Keyboard can be considered as the medium because the user typed the word using the keyboard. So and we do not know the original word and we want to know or guess what the original word could be given this noisy word or misspelled word. So how we can find this original word? So we have all the words in dictionary or the candidates that we have generated, word hypothesis 1 or candidate 1, candidate 2, candidate 3 up to so on, and we want to know which candidate should actually be here. So what we can do is we can pass all these words through this noisy channel and then we'll find these noisy words here and we'll see which of these noisy words is closest to this noisy word, and that gives us a hint that let's say there was a word or a candidate I here and we got a noisy word I for that candidate, and let's say that was closest to this noisy word. That means this noisy word has a high chance of coming from that original word I. So this is how we can guess an original word. So this is the intuition of noisy channel. We'll actually see how this works. At this point, we have already detected the misspelled word. So this X is our misspelled word and we want to find the correct word W bar for this, W hat for this misspelled word X. We have a vocabulary V and we'll find this probability P of W given X for every word of this vocabulary set. And whichever word gives us the maximum probability of P of W given X, that would be our correct word for that misspelled word. So I want you to think about it, how we can estimate these probabilities. What kind of data set do we need to train these probabilities? So we actually require a data set of this type. So this is a typo, that is the spelling mistake, and this is the first correction for this typo, and this is its probability. And then we have the second correction or a second candidate for this typo I and probability for that second candidate, and so on. So to get this type of list, we need a large data set of spelling mistakes along with their corrections. And using that data set, we can find these probabilities. So we'll look through that data set and we'll count how many times this typo I was corrected by this candidate, and we'll find probability using those counts, and then we'll look through the same data set to see how many times this typo was written in place of this correct word, and using those counts we can find that probability. And we can see that this is quite hard to estimate because first we need a data set of both mistakes and corrections. That is hard to annotate, and then we need to find these probabilities. So Bayes comes to rescue again. We can convert this probability to P of X given Y. This is the likelihood, and P of W, this is the prior, divided by P of X, total probability. So you can observe here that this is the probability of X. X is the misspelled word. So when we are finding this total probability for every word of our vocabulary set, this denominator would remain same. because we are doing this whole process for one misspelled word only, which is X in this case. So we can ignore this denominator, because we are taking arg max of this probability. So we are just as denominator is same in all the cases, so we can ignore it. And then we end up with P of X given W into P of W. So P of W is actually the prior probability of our correct word, and this can come from a large enough corpus. We can train unigram, bigram, or trigram probabilities for this prior word. And this is the probability of X given W. That is, X is the error word and W is the correct word. So we want to estimate this probability, P of X given W. For what kind of data do we need for this probability? So we need a data set which shows how many times this word W was written as X. Okay, although we have ignored this P of X, but let's discuss this P of X as well. P of X is the error. So P of X is actually the probability of error. So it is quite hard to estimate. This is the total probability of this error. So that means you'll need some past data to estimate how many times this error was actually made. Now in this formula, this likelihood probability is actually the noisy channel model, and this prior probability is a language model. In next video, we'll see how we can use this noisy channel model and this language model to rank candidates.